Students, in previous class we discussed about the reaction with water, reacting of metals and reaction with oxygen. Today we are discussing reaction with acids. Take the samples given in table 8 in separate test tubes. So in this table some of the samples given now. Take these samples in separate test tubes. Next, add 5 ml of dilute hydrochloric acid to each of the test tube with the help of a dropper. So, in different test tube, we took these samples now. Now, add 5 ml of dilute hydrochloric acid to each of the test tube with the help of a dropper. Means, here once you observe the figure 10, in this figure we can observe test tubes. So, in the test tube what we took, in figure 10 we can observe some test tubes now. So in the test tubes first we will take the samples which are given in table 8. Now add 5 ml of dilute hydrochloric acid to the each test tube with the help of a dropper. So in that figure that girl is adding hydrochloric acid to test tube with the help of a dropper and observe the reaction. If you find no reaction, heat the test tube gently. Okay, if you are not observing any reaction, heat the test tube. If you still see no reaction, add 5 drops of concentrated hydrochloric acid. So, still you are not finding any reaction, then add 5 drops of concentrated hydrochloric acid. Now bring a burning matchstick near the mouth of a test tube and observe what happened. And record your observation in table 8. Do you find any difference in these reactions? We find that some metals react with hydrochloric acid or sulfuric acid, liberating the hydrogen, but non-metals do not react with acids. So repeat the same experiment with the help of sulfuric acid and record your observation. Means first in figure 10 we can observe some test tubes. In the test tube we took the samples which are in table 8. What are the sample? In first test tube we took iron, second test tube we took zinc, third test tube we took copper, fourth test tube we took sulfur, in fifth test tube we took aluminium, sixth test tube we took carbon, seventh test tube we took magnesium, in the eighth test tube we took iodine. After that, and we add 5 ml of dilute hydrochloric acid to the each test tube with the help of a dropper. Okay, and observe the reaction. If you not find any reaction, heat the test tube. Still you are not finding, still you not see any reaction, add 5 drops of concentrated hydrochloric acid. Next, bring a burning matchstick near the mouth of a test tube. Observe what happened. Okay, and record your observation. So here we find that some metals react with dilute hydrochloric acid or sulfuric acid and liberate hydrogen, but non-metals do not react with acid. Here in this table iron is there, no? Iron, zinc, copper, aluminium is there, no? These are reacting with hydrochloric acid or sulfuric acid. Okay, means here sulfuric we took the samples in test tube and we added HCl. No, in the place of HCl we can take H2SO4 also. Okay, and heat it or otherwise observe the reaction. Okay, so in the place of HCl we can take sulfuric acid also. So when we so here this iron is there, no? Iron react with hydrochloric acid and react with sulfuric acid. Zinc also react with hydrochloric acid and sulfuric acid. Copper also react with hydrochloric acid and sulfuric acid. And aluminium also react with hydrochloric acid and sulfuric acid. So from this experiment we can say like this: some metals react with hydrochloric acid or sulfuric acid and liberate hydrogen, but non-metals usually do not react with acids. So here, when do you notice a pop sound is with a burning matchstick? Means here we are bringing a burning matchstick near the mouth of a test tube. No, then what happened? When we bring a burning matchstick near the mouth of a test tube, in some samples we will get pop sound. So what is the meaning of that pop sound? Pop sound is nothing but here when the metals are reactive with acids, that are liberating hydrogen gas. When the hydrogen gas is evolving from the mouth of a test tube, we can listen pop sound. Okay, so that pop sound is nothing but when metals react with acid that liberate the hydrogen gas. Due to the liberation of this hydrogen gas, we can listen the pop sound. So this pop sound indicates the hydrogen is present. Now we will discuss one more activity, reactivity of metals. So you have already seen that some metals react with air and others don't. So the reaction is fast in some cases like magnesium and slow in case of silver and copper. So similarly, different metals react with water and acids under different conditions. Let us explore this reactivity further. So some metals react with air and some are not react, and the reaction is fast in some cases like sodium and magnesium. Means like sodium and magnesium that are reacting with the air very quickly, and reaction of silver and copper with air is somewhat slow. Okay, so similarly different metals react with water and acids in different conditions. So to different types of metals to react with water and acids, it will take different time. So now we will observe the reactivity of metals. Take 5 beakers and label them as A, B, C, D and E. Okay, so in this picture we can observe 5 beakers, no? So label that beakers as A, B, C, D and E. Okay. Next, take 50 ml of water in each beaker. Okay, in each beaker, take 50 ml of water and dissolve a spatula full of copper sulfate in beaker A and B. Dissolve spatula full of copper sulfate in beakers A and B. Next, dissolve a spatula full of zinc sulfate and iron sulfate and zinc sulfate in beaker C, D and E. Means in C beaker dissolve zinc sulfate, in D beaker dissolve iron sulfate, and in E beaker dissolve again zinc sulfate. Okay. Next, put zinc granules in beaker A. In A beaker, now put zinc granules, and in B beaker put iron nail, and put copper turnings in beaker C, and put copper turnings in beaker D, and iron nails put in beaker E. Okay. Next, leave the beakers undisturbed. So leave the beakers like that only, don't disturb the beakers. Next, record the changes in the color of the solution in the table. So after some time, observe the changes in the color of the solution. So which color we can observe? In beaker A, solution turns white. Red mass of copper deposited at the bottom of the beaker. Okay, so in beaker A, solution turns to white and red mass of copper is deposited at the bottom of the beaker. And in beaker B, solution turns pale green. So in beaker B, solution changing into pale green, and red mass of a copper is deposited on the nail and at the bottom of the beaker. And in beaker C, we cannot observe no change. In beaker D also we cannot observe no change. In beaker E also we cannot observe any change. Okay, so here in this we can observe the blue color of a copper sulfate is disappeared, and powdery red mass of copper is deposited at the bottom of the beaker. So blue color of the copper sulfate disappear, and powder red mass of copper is deposited at the bottom of the beaker A. Next, Also notice that in beaker B, red copper is found in the bottom of the beaker and on nail leaving, okay, and light iron sulfate solution, okay. Uh, so we notice that in beaker B, red copper is found in the bottom of the beaker, okay, and on the nail leaving light green iron sulfate solution. What are the reaction behind these changes? In beaker A, zinc displaces the copper from copper sulfate. Zinc displaces the copper from copper sulfate, and giving rise to a colorless solution, zinc sulfate. Okay, so in beaker A, zinc displaces the copper from copper sulfate. Means in beaker A we took copper sulfate, no, first. After that we add zinc granules. So this zinc displaces the copper from copper sulfate and giving rise to a colorless zinc sulfate solution. Next, iron displaces the copper from copper sulfate in beaker B, leaving light green color of iron sulfate. Next, in B beaker, first we took copper sulfate and we add iron nail to that. So, in beaker B, iron is there, no, we added iron, no, that iron displaces the copper from copper sulfate in beaker B and leaving a light green color of iron sulfate. Okay, so in beaker B, iron we added, no, this iron displaces the copper from copper sulfate solution and leaving a light green colored solution, that is nothing but iron sulfate. Okay, similarly, to the reactions in beaker A and B, there is a displacement of zinc from zinc sulfate solution by copper in beaker C and iron from iron sulfate by copper in beaker D and zinc from zinc sulfate by iron in E. Do you find any changes in the beakers of C, D and E? Similarly, here in C beaker we took zinc sulfate. So this zinc is displaced by copper. At the same time, in D beaker we took FeSO4, means iron sulfate solution in D beaker. So the iron which is present in the iron sulfate solution, it is displaced by copper. Why? Because we are added copper, no? Like that, in beaker E, zinc sulfate we took, we added iron nails. The zinc which is present in zinc sulfate solution, that is displaced by iron. Do you find any changes in beaker C, D and E like A and B? We did not see any change in the other three beakers C, D and E. Okay, so in C beaker, D beaker and E beaker we cannot observe any changes. Okay, so here copper is unable to displace the zinc from zinc sulfate, and from D beaker copper is unable to displace the iron from iron sulfate solution, and at the same time in E beaker iron is unable to displace the zinc from zinc sulfate solution. Okay, so we can understand with the above reaction that a more reactive metal can replace a less reactive metal, but a less reactive metal cannot replace the more reactive metals. That's why there is no displacement in reactions in beaker C, D and E. Okay, so see here, we can observe the change in the color of a solution in we can observe here the color of a solution, the solution colors changing in A and B only. In C, D and E beakers we cannot observe any change in the color of a solution. So why? Because in A and B beaker, A beaker, zinc displaces the copper from copper sulfate, and iron from B beaker, iron displaces the copper from copper sulfate solution. That's why the color of a solution is changing. Okay, so like that, this copper not displace the zinc from zinc sulfate solution in C beaker. Like that, in D beaker, copper not displace the iron from iron sulfate solution. At the same time, in E beaker, iron not displace the zinc from zinc sulfate solution. Okay, so by this activity we can understand more reactive metal can replace a less reactive metal. Means more reactive metals are displace the less reactive metal from its compound, but the less reactive metals cannot replace the more reactive metals. Less reactive metals are cannot replace the more reactive metals. That's why we cannot see any change in the beaker C, D and E. So from this activity we can say like this: more reactive metals displace the less reactive metals from its compound, but the less reactive metals does not displace the more reactive metals. That's why we cannot observe any change in C, D and E beakers. Now we will discuss about some uses of non-metals. Okay, so what are the uses of non-metals? You are all aware of these uses of metals. Okay, we know that the uses of metals and non-metals also. Okay, metals and non-metals are useful to us. The three non-metals studied by us are sulfur, carbon and iodine. Okay, so metals and non-metals are very useful to us. So here we studied about three non-metals. What are that? Sulfur, carbon and iodine. Let us know about their uses. So what are the uses of that non-metals? Now we will discuss. Okay, so sulfur is one of the example for non-metal. This sulfur is used in making fireworks. Okay, sulfur is used in fireworks, crackers, gunpowder and in matchsticks and antiseptic ointments. It is found in onions, garlic, eggs, air and nails also. Okay, the sulfur is used for the preparation of fireworks, crackers, gunpowder, matchstick and antiseptic ointments. And we can found this in onions and garlic, eggs, hair and nails also. So activated carbon is used as a decolorizing agent and also used in water purification systems. So this activated carbon, okay, so that is used as a decolorizing agent and also it is used in water purification system. And tincture iodine is used in medical purpose. Iodine is used medical purpose. Tincture iodine means which is mixed with alcohol, that is used in medical purpose. These are the uses of non-metals. Okay, and what are the uses of metals? Have you ever noticed a thin silver foil decorated on sweets and thin aluminium foil is used in packing of food materials? Okay, so silver foil is used to decorate the sweets and aluminium foil is used in inner packing of food materials. And aluminium and copper mixture is used in currency coins. Okay, so aluminium and copper, these are example for metals. This aluminium and copper mixture is used in currency coins and medals and used for the preparation of statues. Okay, next, zinc and iron mixture is used in making of iron sheets. Zinc and iron mixture, it is used for making of iron sheet. And most of the agricultural instruments are made by iron. So iron is one of the metal. Most of the agricultural instruments are made by iron. Next, electrical appliances, automobiles, satellites, aeroplanes, cooking utensils, machinery, decorative materials. These all are made by the metals due to the malleability and ductility and low weight. So these metals are used in the preparation of agricultural instruments and electrical appliances, automobiles and satellites, and in aeroplanes and cooking utensils and in some machineries, and for the decorative materials they will use the metal. Why? Because due to their malleability property, ductility property and due to its low weight. Okay, so now till now we discussed about the uses of metals and non-metals. So our life is depend on this metal. In our daily life, these metals are very useful to us. So these metals play a very important role in our daily life. So these are very useful to us. Without these metals we cannot imagine our life. In our home also we can see we are using different types of utensils, different types of articles. Okay, so in our kitchen we can observe different types of utensils. That are the utensils that are made up of these metals only, like aluminium utensils to store the food items, like that. Okay, and copper utensils, copper vessels. Okay, and iron articles like axe, hammer. Okay, spade, sickle, like the different types of materials that are made up of metals only. Some agricultural tools also made up of the metals only, and electrical appliances also that also made up of metals only. Vehicle bodies also that also made up of metals only. Like this, the metals are playing very important role in our daily life. Without this, we cannot live. Now